Yes, good evening, all of you. So yesterday we have seen Anaconda software and how can we use the Anaconda software to create multiple environments and how can we separate multiple package versions and how it will enable us to separate multiple versions of one software and how I can also maintain my updated version in another environment. All right. With that, it will help me to use the same computer to run my multiple Python projects, which will be going to use different versions of the packages. Okay, that's why we have Anaconda software, which maintains my different environments. That we understood. Then we went to Jupyter Notebooks and we saw how Jupyter Notebook enables us to write the programs interactively. I don't want to write my whole program and then I don't want to click the execution button. I want to write my small program, first two to three statements, and I want to run them and I want to see what will be the output of all those three statements first. Then I will go to write some more statements, and in the middle of the program, I want to see what will be the output. So that way, I want to do part of the program, and I want to check whether everything is correct or not. Okay. So this thing, that means one function or one module I have created, I have designed it, and I want to check how it is working. If it gives an error, I will. And once it is running successfully, according to my inputs, then I'll go to next code. That way, we can also design different types of modules, and then we'll be able to design multiple sections in terms of cells that we have. Okay, we have given multiple places where we can use the Jupyter notebooks. We told in the Anaconda we have two options. One is Jupyter Lab, one is Jupyter Notebook. All right, and in VS Code also we have installed the extension called Jupyter Lab. Jupyter Notebook. So we have a Jupyter here. You can see Jupyter Notebook supports interactive programming. I am computing that supports IntelliSense. That is one of my package that I will install, and debugging and more of them. Okay, so this is one of the extensions that I have enabled to give us the support in VS Code also. All right, so this will run on VS Code, and from here itself we can execute all the programs that we are writing inside VS Code. If I want to write it same programs on my browser, I can also run it from my Anaconda, and when you run from the Anaconda, it will open into web browser, and the web browser becomes editor. All right. For that editor, the backend will be Anaconda itself, who is maintaining the package in the base environment. All right. That will be giving your browser the Python capability to execute the programs on the browser. All right. So these have understood. One more thing, we went yesterday on a cloud, and there we saw on Anaconda website we are registered for free. There we saw Anaconda website is giving us a free console where it is allowing us to write the programs similar to how we are writing in VS Code. But the difference between what we are doing here and on the cloud is there it is allowing us to store multiple files and also allowing us to host one website. Okay, so that it is allowing. Since we need a server to host any of the applications that we are going to develop, that's the difference between what we are doing offline and what you can do on online cloud on Anaconda. Right? That means what? Also, this all of you might have also done that. One more thing we wanted to at this point I want to let you know, because as we are talking about Jupyter Notebook, let's finish this totally. One more place where you can use these Jupyter Notebooks is you have a facility by Google called Colabs. Let's go to that. It's Colabs. C-O. It is a core laboratory laboratory. Colab notebooks allow you to combine executable code and rich text in the single document. Okay, let's enter into this. This is actual website that you have, and this is the logo for that. CO. Here we have an option of open the Colab or a new notebook. I want to open the Colab. So it is giving me this prompt, and this prompt is asking me, do you have recently created notebooks here? If not, presently it has opened directly because I have already logged in into my Google account. If you are not logged in into your Google account, it will allow you to sign in first in the Google using a Gmail. Then it will allow you to open this window and store the files, because whatever files you are going to create on Colab are going to be stored on the Google Drive of your email address. Getting it? That will be the storage for this Colab files, notebooks. Whatever code you are writing will be stored on Google Drive. So I can also read examples from the existing Colaboratory list that we have here, or IPYNB format files. I can click on this option. Presently, I don't have any program that will be stored because by the organization or user. Let us check Kionic 6. Okay, I have the Kionic 6 as username. I'll try to use that name here. Yes, it is telling me I have the code and all of them. All the files are existing. All right. So these are the files that I can also see on my console here. These are my files. All right. This is my module1.ipynb, module2.ipynb, and all of them you can see only ipynb files. Actually, I have all of them. All the code, everything is there, but it's only listing out the files which are having ipynb extension. Any one of the file you can open it and you can start working on it, and it is also given a branch and as well as the multiple projects that you have on the GitHub. Just pick only one project. I can have this one demo website. No, I don't have anything in any file in that. In project 4, we have 2 files. So in that way, you can also browse your GitHub from this website, which is Colab, and you can get those programs in. If you already have uploaded your programs, if you want to edit it here, you can also do that. If you check on to this one, include private projects. Whenever you create a GitHub project, you are asked to create 2 types of projects. If you want to give it to public, or you want to make it private, which are hidden from outside world and only visible to you when you log in. Okay, so it is asking you, do you want to also see your private projects? So you are allowing GitHub, Google Colab to enter into the profile of yours in a GitHub and then access all those private projects. Since they are private, they are taking a license from you and permission from you to enter into GitHub. So I am allowing them to enter, and they are asking password. And now they are also listing out, I think, one private project. When we have given a demo of private project, we have only one. So all the 4 projects, earlier there was only 3. Now it is showing me all. All right, this will show me all private address, and I can start executing that programs. Right. So presently I don't want to upload any of them. I just want to create a new notebook and I want to just execute one program. I just want to test it. Okay, let's go back to recent, and I need a new notebook. Here I have an option called new notebook on the bottom. So when you click on this new notebook, it will create and allocate some cloud resources to you as a Colab user, so that your programs can be executed under that computation capabilities. Okay, let us see what are those. So presently, this is the interface that we'll be having. You can also see there is a logo is coming on your behind your file name. That means this file is already stored on a Google Drive. I mean your Google Drive space. So you can also rename it here itself. I'm renaming it like my new notebook. Okay, notebook 1. If you click it outside, the name is changed. So here you can write. Here we have the usual file, everything. You have that. You can have a look at that. Here you can write your programs. I'm just going to write a print or any statement. You can write it. Just writing hello world, and this is my place where I can click on and I can execute the programs. Control, press enter. They say I will execute the statement. Alright, let us play it once with the mouse cursor. So it is running it, and at this corner you can see it is saying it is connecting. What is connecting? It is allocating you the machine. So presently it is connected. Okay, let's reconnect. When it is allocating you RAM and a hard RAM. Storage is already in the Google Drive, and it is allocating you CPU capabilities. Right? Okay, let it initialize. Okay, connected. So I have the RAM as well as my system disk is been allocated already, and they are the resources allocated for you as a Google user. Python 3 Google Computing Engine back. Showing resources of 5 at this point. I mean, at this time, the system RAM of 12 GB, and so system hard disk that has been allocated. 24 GB out of 107 you are presently using. Alright. Okay. So if you want to upgrade it, you can obviously upgrade it to any of the higher resources. Presently, we are just okay with this one. Yes, so this way you can actually execute your Python programs interactively. This is your IPYMP format on a Google Colab. I hope all of you have understood the capabilities of Colab. And if you want to install anything, like I want to install something, I will have the prompts, terminals. Sign up for Colab Pro. To gain access to the minimum Studio Code, here you need to sign up for Pro version. That means you need to pay them in the Pro version, where it will be available. Okay. So I want to have a cell into this one. I can click on this code. If I want a text here after this one, I can click on this one and I can give a text here, which will give me the text that I have written. I can also format it, and I can also make them this, and I can just save that. I can just click outside. My text is got saved, and this is how I'm going to have the text being written as a headings or some text that I want to explain about the program. Okay, yeah, I was talking about how do I install the package, pip install. Now I'm going to check it here. Pip install will install tkinter, and I'll say please execute this pip install. So it says looking for indexes in this one, could not find the version satisfies the requirement of tkinter. Let us try another package. It is giving me some no matching for tkinter, numpy. I think it is asking for the versions that it has to install. So it is installing numpy. Requirements already satisfied. That means it has already installed this package in its environment. All right. Let us check another one called pandas. I hope you understand now how do you install the packages. This is how you can install the packages. Okay, requirement already satisfied, and it has already installed all these packages. The base package that it has it. That is how you can use Colab to install the packages, and you can interact with your own file here.
Sir, in previous code, we used to write this pip install in terminals.
Ah, yes. Here it can also
editor methods of
because directly these commands are going to the server itself. So server will take care of what this command will do. Obviously, all the statement that you're writing will be considered as command itself, and it will detect what kind of a command you are sending it.
So in VS Code, sir, whatever we write in the editor, so that will go to the VS Code interpreter or
Python, because it's related to the environment.
Whereas whatever we write in terminal, where that will go, sir? That will go to.
That will work as a system command.
CMD
System
command.
command. System command. So system is operating system. We always say system. It's operating system. So who is that? It's a manager. You are asking manager, I want these resources for my program. So it will get the resources from internet. You are not telling from internet you get this thing. You are not instructing the manager. Manager already know how to provide it. So we are just asking what I want. I want numpy. If you install numpy, install it. You connect to internet, you go to offline, you ask somebody what should I do? You provide me the package. That's how I ask my manager to give me that.
In that case, sir, why can't we write this script install in editor window, sir?
Because it considers this as a Python program. My interpreter will look for
a Python statement.
Yes. If it doesn't find a meaningful statement, it raises an error. That's how it goes.
So, sir, terminal at the bottom of the in the VS Code and the one invoked through this command here.
Okay.
So, are both of them same, sir?
No.
How they are different?
They are same in terms of functionality and as they're installing packages for the environment. In Colab, we are installing packages for this environment. I mean, presently whatever is activated, we don't know what is activated. Presently it is activated and allocated my resources. Here on your system, there are multiple environments created, and it is installing your offline packages. I mean, offline environments. So both are different. That is on the cloud, and cloud is different. And here we have different. And interpreter way also is different.
Then how this command prompt is different from the one at the bottom of the VS Code?
Yes. So here on my operating system locally, we have a Windows 11. That is going to be a single system which only install the commands which are registering. As pip is getting registered once I install my Python. When I install my Python software, it knows that command. Before I install Python,
This command prompt.
yes, my system, that my operating system understands whenever I want to interact with my operating system, what I do, I'll open the command prompt. And that will be my interface to communicate or talk to my operating system. So that black screen is not the small window where I can type. It is actually my operating system talking to me through my commands. So here it is doing the same, but you have a server operating system in a larger way, which is controlling the allocation of resources. And somebody has allocated me a resource of RAM and the hard disk, and it does not mean that I am having a separate operating system. I will just create a process which is handling my requests, and that is being fulfilled by the operating system indirectly. So cloud systems are definitely different from the individual system. Here we are locally, we can say that locally who is executing. Here we can't say who is executing. So that will be there. So that's why here we have a terminal available, but that is only available for the people who pay them in the pro files, professional files. So then you can access the same thing what you are doing in VS Code, you can do it here also. But rather than that, also we also have a method. All right. But let's go ahead. So this is one of them. I hope you understand that. Whenever you have requirement of not to install any Python program, I don't want to install anything, but I want to test my program. Directly come back to Colab. Once you are logged into your Gmail ID, you are obviously available with the Colab. Come here, paste that program, run it, check it, modify it, check it. And if you want to save it, it's already saved in your Google Drive. You can see. Later also you can check this thing. I will understand that. All right. Any questions? Any questions? No? Okay. playground. Just a second. I'll go back to my. Okay. If you look at the examples, we already have a lot of examples here. Form snippets, panda snippets, Google Sheet snippets, all of them are already ready code available, which you can use it in your programs. Okay. If when time is there, you just go through these all tutorials that are there. Whichever one you understand, right? You go into them and you can have a look at them. So we understand panda snippets that we are about to learn. So these are the small snippets that they have written in, small programs that they have written in. Okay. Later, once we finish pandas package, you can come down to this one and you'll be able to have that. And all the problem statement that they have done, they are already listed out here. Alright, a better section for you to refer this. Let's get back. And on VS Code also, we are able to use the IPYNB format. My IPYNB says I am an interactive Python, interactive Python NB notebook. Together makes it IPYNB for interactivity, PY for Python, NB is for notebook. So IPYNB is the extension for a file which opens an environment like this, which is having multiple cells of the code, and also it will mark down for you to write down some explanation of the purpose of it. Okay, I hope we all know this one and we have understood because we have already studied a lot more things on this file. Alright, let's get back. So let's get back to the most important topic, that is numpy basis. This numpy, if you look at it, it's a numerical Python. The numpy is a numerical Python. It's a Python library used for working with the arrays and lot more other data structures. Was created in 2005 by Travis Oliphant, and this is one of the packages which has a lot more to do with the numerical calculations or numerical manipulation. The most important object defined in NumPy is called n-dimensional array. N-dimensional arrays. You understand what is the dimension in terms of arrays? If you have one-dimensional array, that means only the numbers will grow in one direction. You go on right at commas. And if I say two-dimensional, that means your numbers will grow in two directions. One is in x direction, one more is in y direction. In that way, I can also say that two-dimensional arrays are actually the matrices of any array. Is that right? Okay. So we can also call them as NB arrays. It creates an okay. Let's study some more thing about NumPy. There are a lot of interesting things about NumPy that we can go through. It is general purpose array processing package. General purpose array processing package. So it is not specific to any of the programs or projects that you are going to use. So this is a general utility package. That's why you see this is being used in most of the advanced packages which they are developing. When they are developing advanced packages, so they use these packages. I mean, they use the capability and they develop an advanced package. So whenever you want to install the advanced package, this will be installed first because their capabilities have been already used in creating the advanced package. Alright, so that's why it is said to be a general purpose array processing package. So when you talk about array processing, you can think of your tensors or TensorFlow packages which were intensively working on the matrices. Okay, called tensors of multi-dimensional arrays. Okay, think of image processing where you'll be considering multiple layers of your image data. They're all you'll be using these packages as a base packages for those advanced packages called tensor packages. It provides a high performance multi-dimensional array objects and tools for working with these arrays. Tools means they are having multiple functions to handle such operations or to manipulate those data that you are going to store in these data structures. Okay, it is a fundamental package for scientific computing with Python. Its obvious use is numpy and also how do you define an array? As we just spoke about array, numpy is general purpose array processing package or a Python package. All right. So numpy dot array, it creates a n-d array, n-dimensional array from any object exposing an array interface. Or from any method that returns an array. So we can have checking numpy version, import numpy as np. When you write import numpy, that means all the packages or all the functionalities or all the files that are available in numpy package will be imported for this program. Alright, and when you say as np, you are actually shortening the name of numpy to np. Alright, and this np must be a valid variable name or identifier name. You should not write or violate those rules that we learned in the introduction, saying that you should not start a variable name or identifier name with number. Alright, that you should follow here also. No excuse for that. np is our name, shorthand name, dot underscore two times, version underscore will give you the version of numpy.
So why two underscores?
Because they have been identified in that format. And not only that, we also do that for image. We also do that for many of them. And one more thing is that there is a type. We already know about this one. This built-in Python function tells us the type of object to pass through the type function. Okay, let's do all. Okay, I import numpy package. If I am importing it and if it is not giving you any kind of a warning or error, that means numpy package is already installed. If it says numpy is unidentified, then that means you have to install the package. Alright, so how do we install the package? We use the command for pip space install space the name of the package, and the name of the package is numpy. Please enter that, and we press enter in the terminal. Alright, let's go back. We have the import, then we have numpy. Yeah, I have the numpy. Is available. I am getting it in a suggestion. As I said, np is also being suggested to me. So I can see some blue marking here. what does it say? It says it's an unknown word, not an unknown package. Right? So it says I have installed a C spell. That means it is checking my spelling. If it is not there in the dictionary, it gives a blue underline saying that there is a spelling mistake. But we are having numpy spelling correct. Actually, we need to create a dictionary for a programmers, Python programmers, so that programs spelling can be checked. That is actually done by a debugger. Okay, import numpy as np, and I am interested in looking at the versions of it. Okay, I can write numpy directly, or I can use np directly. When I am defining numpy, it does not mean that I can only use that. np dot. I have not selected the kernel because it is giving me completely black, white text. Let us select my kernel here. Can you see here on the top right corner? I have an option called select kernel, and here I have 3.11 and a lot of other kernels available. I'll click on them, and I'll just say my base kernel I want to activate. So my base is activated now. Now my program is becoming colorful. Because my kernel is looking for what are things are there, it is giving you a color and giving you the programs. Let's look at it again. Now it is able to understand what I'm writing, and it is also now trying to find out the errors. Earlier when we were writing, nothing was found. Now it is dynamically compiling and debugging. Fine. Cool. Let us do that now. I have a lot of functions connected to that, and I'm only interested in the doc strings. I have all of them, but I need the version. Yes, I'm ready with this one. I'll run this. And for connecting, for running also, you have the Control Alt and Enter. Okay, it is running. Only first time it takes a time to run that, and once you run one time, it's getting connected to your background server. Then it will need to give you a quick results. Okay, it has given me some problem. It says fail to start a kernel. Let us check another kernel. So it says something. Failed to get activated env environment pairs for this exe it is saying. Okay. Now it has retried multiple times and it is giving me the version. Alright. So it has executed and told me that you are presently having version of 1.24.3. The same you can also verify from the understand where these packages are there and what are the documentation for that package. Let us type in Google numpy. Oh, this is numpy. You'll see the package separately maintains the documentation and also available in PyPy packages. This website you can remember to browse whenever you want to look for any packages. Like I want to have some packages for something, so I can also go for that. That is py.pi.org. Will give you that, and presently it is having 1.25.0. So if you again install your package and then check your version might have got upgraded. Let us do that. I'm going to go to this place. I click once, and I see my terminal is available. And I'll check my environment here. My environment is activated as base presently. There I wanted to check. There I want to actually update my package. So this is how I can update, or I can also write my package number by writing a equal, and then I can write my package number version that I have. Okay. If I do not mention the version, so by default it look for the newest version, the latest version, and download. Let us install it. Where?
In the terminal, second line. So base environment.
This is connected. Okay, my this one old package is it should go to this package.
That is connected to the old storage folder of the data.
Yes. Let us check here what is the version. Defaulting to user installation because normal site package is not writable. Okay, my base version is giving me the issue. So I can use my other package that I have as 3. Okay, I have this one also, that is global env. I also have 3.11. So in 3.11 it is there. So I can use this one as well. 3.10.9. Asking me to install my kernel. No problem. So you can just switch to any other package and you can just continue because you just need to see the version and just you need to continue the theory. Alright, let it install. And also you can check any type of what type of object you have with the type of type that you already experimented earlier. Then we have numpy.array object. Array. Then you can have any of the shorthand operator .array will give you an interface to create an array, and you're going to use the object, then data type. Presently it is none, b type, then copy, then order, and none, and sub okay, false, and n type. So all of them has been explained here. So first is an object that you're going to give as a parameter to that. Any object exposing an array interface method returns an array or any nested sequences. Okay, you can have any type of data structure that you are having, which will give you capability to store those elements there. Then we have data type, the desired data type array of array, an optional copy of optional. You have a copy as optional. By default, true. Object is copied, and then you have order C, that is row major or the column major, or any default. Then you have sub okay, by default return array, forced to be the base class of an array in the numpy. If true, then subclasses pass through this array interface. N being minimum, okay, n dimensional minimum, specifies the minimum dimensions of the resultant array. Okay, we'll see one example on this so that you can understand it clearly. We are going to create an array of 0 dimension. Okay. You might have not heard of this one, but look at this, how we can create a 0 dimensional array. This is my 0D array. Import numpy as np, and you can say arr array, any name you can give, equal to np, which is my shorthand, dot array, and then 42. Just one element, nothing, no square brackets, nothing added here. So when I print it, only my number is getting printed. That's the 0 dimensional array. That means they are not specified what. When you have one square bracket, one in number, square bracket is added, then we are making it as 1 dimensional. Understand? Now, if you look at the, please having a square bracket. Earlier, for a zero dimensional, I don't have any square bracket that's been added. The code it does now. If you look at a two-dimensional array, what do you have? You have two square brackets open, 1, 2 closed, comma, one more open, 3, 4, 2 closed. That means there are two square bracket group available inside one square bracket. That means you have two-dimensional list that you have created earlier. Same thing added to the numpy array. Now we are calling obviously. Our data structures. Here we have facilities are different. They look same, accessibility same, they work the same. See, basically, if we look at it, why we use such data structure is the question. You store the numbers, there also I'm storing the numbers, there also I'm storing the numbers. But what makes the difference is the facilities given by the list to manipulate the numbers. And here, manipulating these number capabilities are different. Manipulation capabilities makes a difference. They're also storing same data two-dimensional list. They're also saying the same. And they're also calling it as a matrix, two-dimensional 2 cross 2. Same. Capabilities of manipulation is different. Okay, more here, less there. When you say two-dimensional array, you have two groups of square brackets added. So that makes me two-dimensional array. When I print it, I will be printed like this. Earlier, they used to be printed in a list. Now they print it as a matrix. Okay, let us try these arrays on the console. Okay, do we have executing? I think it executes. Let's take a new code. I'll import, and in the IPYMB formats, you can skip importing statements in the next cell because you have already imported one of them in one cell. So the whole IPYMB file can be considered as one file, but they have been divided into multiple cells. Alright. Once you have written all of the program, you can also click on this button called Run All. Means all the cell programs will be executed one by one. Okay. So I can skip writing this import statement here, and I can directly write my end dimensional array. And use the same NP. Let us look at that. NP dot. I can have array. We have array. I have the array ready, and I am going to see there are a lot of parameters. Have you understood the parameters? We just saw the object, an array, an object exposing the array. We have the sequence or any of the nested sequences we can have. Okay, any interface, any array interfaces that you can have, that you can mention it as an array. Then you have data type, that is optional. You have a copy, that is also optional. All of them are optional. So one is compulsory for you to mention is an array like data structure that you have in Python that you have to mention it here. It may be list, it may be double. Okay, with that, let's go and create an array. So I'll write 10 here. Is it allowing? It is allowing me to print it. Okay, I just print them. It is printing me array of 10. I want to print my array that is being stored in ARR. This presently this will not do any printing. When I just directly written without ARR equal to, it is printed array of 10. Now if I, this is my equation, this is expression. Expression doesn't print anything. Now I want to print my output like this. Now I'll print this thing. Right? So next I want to print my one-dimensional array. How do I do that? I just have to use my square brackets inside this, and I'm going to write some number. and I'm going to print that thing. I'm going to print an array. Right? So that's how I'm able to print multiple elements with the help of the array that I have.
So in second of array of 10 is that telling that this array can contain 10 elements.
No, that is one element. As you can see, this is array 42 means 42 is one number as an element item.
That is one object.
One object.
Can you add that to one more object in that?
Yes.
Along with that?
Yes. So I can have comma, and this is my list type, and I've added 11. One more number added. So that is a way. So if I print it, I'll write print ARR. I'm printing ARR. I'm having 10 and 11 being added.
So instead of np.array, we can make use of np.list also.
np.list. In np, you don't have list, you have array instead of list. You have directly list, you don't have to access anything for. You don't have to refer to object and then put a dot and ask the list. You directly have the list in the Python package. Python interpreter will provide the basic data source, so you don't have to ask him. It is like you're asking numpy to give me a list. You don't have to do that. All right, we have two-dimensional array, so you can use the same tools. You can use a two-dimensional array as well. So I just have to group all the elements. So I have now one element. I want two elements, but those two elements must be inside my square brackets. Now this is my two-dimensional array. I want one more element to have one more 11. And I want one more set of values like this. And now I have two-dimensional array. Right. Obviously, it is getting printed like this. I have to print, write a print, then only it is going to print you without the name array. This is how it looks like the actual matrix that we were earlier looking for. We are expecting like this. Now it is possible in numpy. I told you in that class that in numpy we will be able to display this. This is that. All right, let's go ahead. That's two-dimensional array. Then we have three-dimensional array. When you have three brackets or multiple groups that you are adding, see the nesting you observe. Nesting you observe. You understand the nesting, right? Let's understand the nesting part. One array started. This is my common array which is closed at the end. Okay. Here open and here closed, the last bracket. Alright, next, this second bracket started. Where it is closing? Here it is closing. Alright, next, how about this is closing? Here itself. Comma, one more it is closing here. That means this bracket is having two of them. Two set of groups it is having. 1, 2, 3, 4, 5, 6, 4, 5, 6 are one group. Comma. After this comma, I have one more group of this full thing till here. I have one group having two set of elements. 1, 2, 3, 4, 5, 6 again are having one group the second time. So this nesting will give you a dimension. Alright, that's why we are making it as three-dimensional array. Alright, let us see all the dimensions one by one so that we can understand as well as differentiate between multiple dimensions. That will give us more knowledge on how it is going to be displayed. Okay, the output look like this. Same thing. Okay, let us create all the types here. Okay, I import again. All right, I want the NP to be NP dot array. I will use my 10 as a number for my which type of array? Zero dimensional. I just write 0 and capital E. I have NP dot array. I am having one dimensional array. I am writing a 1 comma 2. Okay. What should I write here? It's 1D. Okay. All right. I have NP dot array. Now I want to have two-dimensional array, so I'll use one more group inside bracket, and I'll also put a comma, and also write 3, 4 values. 3, 4, I write it, comma 4. This will be my two-dimensional array, and I want to have NP dot three-dimensional array. So how do I start? This is important to understand. I have one bracket ready, my second bracket ready. Now I want to just create the brackets. So this is one of the group, and I will have comma, and I will have one more group. Right? Now two group ready. Now in one group, I want to create two elements, two brackets. All right. So let us write that. I just separate it a bit, and I write this one, comma, this much. You understand the structure first, then we'll write the elements into that. Okay, here also I'll do the same. You understand these all different colored brackets. You understand that? That's why we are calling this what is that? Three-dimensional. You understand all of them. Brackets you understand first. Here, scan. Fine. Let's go and add elements. Where should I add elements? Only in the yellow brackets. Only in the yellow brackets. Let's write them. 1, comma 2. Right. Comma 2. I have 3, comma 4. I have here also elements. Like I'll write the same numbers. I'll write the different number. 4, 5, 6. Then I have 7, comma 8. Okay. So these are my numbers that I have added for the three dimensions. Now can you understand how nesting has happened? In terms of color, you understand. Pink color bracket is a main bracket that is enclosing everything. If you just keep it flipped, it will encircle that also. You can see both of them. This is my one dimensional that I can see here, 1D, the first bracket that you added. Then we have this blue bracket that is being added, and that is giving me the second dimension. All right, that is giving me the XY feeling. XY feeling. This is my X. This is my Y. Then we can see with this one, I can see this 2D effect. This is my 2D effect, and that means the overall 2D effect. This is my one element. This is my another element. Okay. Now I'll go into this yellow brackets. So how many elements do I have? I have multiple elements into this one itself. In this brackets, how many elements you have? 2 elements. Okay, I can have multiple elements, not only 2. I can have multiple elements. I can have 0 also. No problem. It's up to us how many elements we want to add. All right. So that way, I can make it as 3-dimensional array. Isn't it?
In 0D, there are no square brackets. In 1D, there are only one pair of square brackets. In 2D, there are 2 pairs of square brackets. In 3D, there should be 3 square brackets.
Yes, that will be a better way to understand. I mean, remember. But nesting will be one of the ways you can think of. Obviously, that will be one of the ways that you can Remember, I'm writing 3 brackets 3D, same pattern that you see. Is it understood? Let's get back. Okay, we can play with this one, but we just need to write print to all of them so that we can print all of them. Obviously, they'll print as numbers, everything. Okay, we have, and what is the problem we have? Setting an array with an element with the sequence. The requested array has inhomogeneous shape, 2 cross 2 dimension. The detected spawn shape was 2 cross 2. So the dimension we are adding, I think added 3. We have added. So now it is going to match. Yes, now it is matching. It is very serious with respect to the matrix ventilation because its whole existence depends on its capability to process the matrices. Okay, so existence in Python is for the matrices and its manipulation in terms of an array as a name. Let's go back. I have all here understood. Let's go ahead. Create a 3-dimensional array. So more than 3-dimensional array, or 4-dimensional array, or 5-dimensional array, or 10-dimensional array. Continuously when you go, you write in mathematics also n. 1, 2, 3, 4 till n. You write it. So here also we are saying them as we can create by n d mini arguments. Example: create an array of 5d. Create a dimension of 5d. Array equal to np.array 1, 2, 3, 4 is my list of numbers that I am providing to an array, and I am asking it to create and make it as n-dimensional array. N d minimum, that is 5 is the number. I want to create 5-dimensional array. So with this, you can maintain or tell or mention what dimension of array you are actually trying to create without writing or worrying about how many brackets I have in my array specification. Okay, shall we do that? Okay, let us take it. Shall I mention it here itself? We can do it separately since it is a different thing. N d min.
So in 3-dimensional x, y, z.
X, y,
Z.
X, Y, Z.
That's the values.
X axis, Y axis, Z axis.
3-dimensional.
X, Y, Z. Correct.
You have to take only to x and y.
Where?
Last line.
Line number 9.
Where is the z value is asking, sir? X, Y values are there. Where is the z value?
It is not about the X, Y, Z. It is about the matrix you are creating. 3-dimensional.
3-dimensional. 3 cross 3.
2 cross 2 or any order you can take, but it is 3-dimensional. So how do you imagine 2-dimensional?
2-dimensional. X and y.
One plane. Having some numbers. Another dimension if I add
3-dimensional.
3-dimensional. So how do we imagine? We have some more values behind it. Okay, that we are trying to represent, but it is not displayed all of them. So we have only 5 and 16, 5, 5, 6, 7, 8. Yes, 5, 6, 7, 8 is being displayed. 1, 2, 3, 4, 1 is being displayed. 1, 2, 4 is being displayed here, and they will be displayed here. And the bigger space in middle will show you that both of them are not related. I mean, both of them are related immediately, and these are not related. They are of different dimensions. Okay, that is how they are actually the box kind of thing, and you are making it as a 2 cross 2 cross 2. 2 cross 2 cross 2.
Yeah.
Okay, so I want to divide it by 2. So these are my array elements, and there are also elements which are behind. I am not able to see that. If you want to see, you can just draw the dotted lines with this one imaginary line, and you'll be able to see them also. Okay, that is the behind it. Just focus on these numbers. This is my 1, this is my 2, this is my 3, this is my 4, and these are my elements that I have. And these are my elements here: 1, 2, 3, 4, 1, 2, 3, 4. So all the elements that I have will be behind this one immediately. So how many elements we have? There. 1, 2, 3, 4, 5, 6, 7, 8. So how many total? 8. 8. So how do you arrange them? 8. 4 of them at the front, and 4 of them in the other dimension. I mean, other dimension. Other dimension. On the other dimension, behind this, here are all these elements added. Okay, the plane being added. So that way we can add this. This will be one of the tensor that we were talking about earlier. Our main agenda behind why we are learning this is because we are interested in image processing. We are interested in video processing. We are interested in video manipulation. We are interested in identifying what is going on in the video, what is going on in the image. Okay, and all the media that I am talking about are actually having digital values as called pixels. And all those pixels, I am considering them as one of the values. I'm interested in those pixels. That's why I'm interested in these square numbers. I'm interested in manipulation of those images and video. They are not one-dimensional arrays. They are two-dimensional arrays, having the multiple layers in those videos as well as images. That's why I'm interested in this one, not the single layer. That's why I'm interested in writing my programs in multi-dimensional arrays. All right. So let's go ahead with the n dimensional array. That's ND. So how do we write that? NP dot. We are going to write an array.
N is for n, sir. D is for dimension. What MI stands for?
Minimum 5 dimension. Here we have, I think, explanation for the ND min. We have a copy. We have a D type.
As we do control F in that box.
Control F means here only control F.
Yes.
No, we can't do that. On data type. I think we have also opened the numpy GF here. We can also see that. I think we opened only the GFG is numpy, but numpy tutorial will give you in the all the parameters actually. All the topics. This is different.
So we need to type these B and C. Your house.
No, you just need a array method. This is arrange. Not having. Let us experiment it and let's check it. Let us have the list here with the numbers 1, 2, 3. I have suggestion. I'll take these numbers and I'll ask them to create a n dimension n d m I n. Okay, so I need to provide a number here. Okay, I'll start with the 2 dimension. Let us write that. You know what is 2 dimensional. So here it is. Okay, let us print it. Okay, this blue underline, all of you know why it is coming. The blue underline. Why we are getting blue underline? Dictionary error. That is, it's not a spelling which is matching in the dictionary. That's why it's coming. All right. So this is my 2 dimension. Let us now increase the number. Let us pick it 3. Just added one more square bracket to that. I'm going to add 4. Added. That's how I can add it. Instead of this one, what I'll do, I will add already I am having 1, 2, 3, 4, 5. So here is my one of the bracket and here is my another bracket. I'm going to have one more bracket here. Yes. So I'll try this one. So it's going to give me the 4-dimensional array with 2 elements available. Okay. Then I use my find and just add it with a number of brackets. You just check the nesting. I'm adding a 6. It is giving me the numbers. I'll add a 10. I'm having 10 brackets here. That means it is giving you the facility to add elements in between also. Alright, that's your n-dimensional array. That is ND meaning. You can create multiple dimensional arrays. How do you check the dimensions? How do you check what dimension your array is there? You can check that with the help of NDIN. Okay, n dimensions. Using the keyword ND, you can use. This is my A, which is which dimension?
See,
It is zero dimension.
zero dimension.
This is of one dimension. So you can see 190 here. Alright, you can do that with the existing program itself. If I want to find what is the Yes, any question? Okay, I just want to know print. What should I write?
Yes.
ARR
AR dot
dot
N A N
D
N
N I M. What I'm expecting? I'm expecting this number. If I remove this, okay, exactly. Okay. So that is one thing. That is ARR.NDIM. That way you can understand the dimension, and this is being used multiple times when you are in the machine learning program, and also in OpenCV when you are actually handling the media data, like images and videos. Right? It is obviously needed because what type of data you are handling, that will be known with the help of dimension system. Checking the shape of the array. This is the, in terms of matrix capacity, it is order of the matrix. Shape is the number of elements in an array. The numpy dot shape or np dot shape and the array name you have to provide in the parenthesis will be given the return value as a number. I mean as an order. Array is passed as a parameter. The return value will be a tuple having these parentheses. Tuple whose elements give a length of a corresponding array dimension. So the returned value will be the tuple. You need to remember this. So you do not, you show so that you do not perform any other action other than the tuples methods on the return value. You understand that? The return value is in tuple format. That's what I mentioned. All right, I have to have an array dot shape. So I just printed the dimension. I also want to print the order or shape. Okay, now what should I do? I want to find the shape of an array. ARR dot shape, then dot array name. So what is this shape now? What is the shape? It is a function or it's a method. Okay, it's a method. Okay. So what are you looking for? What are you looking for? You're just calling shape to get to know this one. Fine. You can do this one or you can do this one if you are ready with the array. Alright. So you just told me this one. So that will work. Yes. So this is the array dimension, that is 10. So if I make it 3, this is my 3 dimension. So what is the order now? It's 1 cross 2 cross 5. This is the order of the matrix. I'll remove all of them. I just provide the list here. And I'll tell I am having a dimension of 2. This is my 2-dimensional matrix. I'm just doing the numbers, you convert them into 2 dimensions. So it says I have presently 2 dimensions, that is 1 cross 10. Is that right? Okay. I make it 3 and let's see what is changing in the numbers. Just observe this number. Presently it is 1 comma 10. I have 1 comma 1 comma 10. Is that right?
So 1 comma 1 comma 10 means
I have x value 10. Y value.
row and column.
How many rows I have?
1 row.
How many columns?
10 columns.
Y and Z are ones.
Another one is
Z axis.
I, J, K.
Width, the height, and the depth. Depth you can say. Depth is how much? 1. Height is how much? 1. Width is how much? Is 10. Okay. So that way you can just look for that, and I'm going to divide that thing in terms of matrices. And I just remove this thing. I just don't mention that. I just use it my brackets to tell them what dimension it is. And I'm just asking them what dimension it is. They're saying 2 cross 5. Is that 2 cross 5? Is my matrix is 2 cross 5? Shall I print this? I hope you are not getting it. Yes. This is my matrix and this is my order. You understand that? Now you understand. This is my 2 comma 5. Agree? Okay. So what I do again? I do this one. Now it is saying 2 cross 1 cross 5. I added 3 brackets. 2 cross 5, we understand. 2 is rows, 5 columns, and 1 is Z axis, only 1. Unit. How can I make it 3? This one 3. This fits. How can I make this 2 as 3? 2 comma 1 comma 5. Have this matrix ready. Presently 2 rows are there, 5 columns are there, and 1 is 1 common. Nothing is there. So I have ordered 2 comma 1 comma 5. I want to make this 2 as 3. How can I? One more.
So another number
5 elements I need to add.
another 3 brackets.
3 brackets.
Comma.
Enclose array in one more square brackets.
This much.
Yes.
Okay. So it is giving me some error. Where is the error? Double comma. It is. This is right. This is okay, right? 5 elements was same thing there. 2 comma 1 comma 5 was there. Now it is
3 is a row. 1 is a
5. Yes, correct. 5 is the column. That is there. Okay, so that way you can control the order or shape of the matrix, or shape of the array. Okay, that is called a shape of the array. Besides creating an array from a sequence of elements that we are mentioning from our side manually, typing 1, 2, 3, 4, you can easily create an array filled with zeros automatically. For example, I have a matrix of 100 across 100. I don't want to type all the 100 numbers. I just want to initialize with some number, like 0 I want to mention. So with that, you can use automatic methods to fill all those matrices with some zeros. And we have a method called np.zeros and comma will fill with a 2-dimensional array, that is 2 order. So it create an array of 0, comma 0, or an array filled with ones. Np dot ones, comma 2. And it will give you these kind of arrays. That means with 2 elements. You can create an array with a range of elements. Np dot, it is not arrange. Check the spelling. It is not arrange. It is a range. Arrange will have 2 R. A range is having only 1 R. This works similar to your range that you are using in for loops. You use range in for loop. You use it. That range spelling is saying we just added a here. Okay, it is arrays range. Remember that. Okay. We have a. We can create an array with a range of elements. A range of 4 elements. So we have same behavior as its pattern of range here. We told earlier that the range will generate a number starting from 0. Same thing. Yes. Is that alright? Let's go ahead. And even an array that contains a range evenly spaced intervals. Through this, you will be specifying the first number and the last number and the step size. This we did earlier also. Start, stop, step angle. It's how much jump I have to go. 1, 3, 6, or whatever numbers I am going to give, that jump I have to mention. Okay, let us try one by one. Okay, when you mention these things, you'll be able to have these arrays being filled with. I have filling arrays. Or we can take a systems and execute it so that we can understand it thoroughly. So we just listen. Just remember temporarily. Okay, let us try with I'll just use import numpy as np, and I will be going to use my np dot array. Okay, I need to initialize my number. I can use np dot 0, and it is going to be returned a matrix. Will be returning a matrix, and that matrix will be in terms of an array that you need to receive it and print it. We have np dot zeros will create a matrix and send it back to you. So you need to have a return value. So I will have ARR as my return value, and I am looking for a function which will generate my matrix. Who will generate? NP will generate, or numpy will generate it. Okay. Then dot, I'm going to check with the zeros. I have array. Alla, you same pressure aquí anta. Clear. Manually zero direction. Let us create with a small number. Then we create a larger number, like 100 numbers now every time. Let us see. We have an array as a. I'm receiving the matrix that is being created automatically. Yeah, that's how I can check. I can print my ARR also. Let us print my ARR. This is what I want to do, and I'm going to give my 2 here. Let us play this. I'm having 0, 0. That is my 1 cross 2 matrix. All right. Okay. I'll increase my number. I'll increase it to 4, and I'm having the list is being sent as an array. I mean, the return value is the list I'm saying. All right. Okay. Now I can use other elements, other method. I have an array of ones. I can use it. I'm just going to take a new cell, but I'm not going to import again. Same import statements I'll be using here also. Okay, let us directly go with ARR equal to np dot once. Here I have, and I'm going to take the parameters here. So here we have some parameters that I'm going to specify the shape here, int or sequence of ints, shape of new array that you can specify here. Example, we just gave 2. You can also give 2, 3, or else you can give 2 directly. Okay. Optionally, there are other parameters that you can look for later, but just understand what we are trying to do. I just use my 2 initially, and I just wanted to print them. Just copy paste this thing, and I just enter them. So I have 1, 1 or 1 cross 2 shape array ready. I want 2 cross 2 matrix, 1, 1, 4 times around. Then what should I do? I can give here, comma, 2. I'll give, what do we have? Okay, we need to have a data type provided. We could have provided the data type for that. Okay, all of you type in. Let's type it. It's 4 cross 4. Okay. Do it quickly. Just check it here. Just once. Check with the multiple orders. Take tuple values. Because earlier when you are actually displaying, not displaying, this order, tuple particular, the output is tuple only. A shape model, we have given tuple as output. Same we have to give input now. The same number that you have took output as a np dot shape or ARR dot shape, output was tuple you are having 3, 1, 5 was the output as a shape or order. Same thing you should provide inside the zeros or ones also. Alright, try now. Try it here. Instead of 2, put the parentheses, then provide the order. Do that. 2, 2 I want. I'll be able to have 2, now if I want to have 50, 50, I am attempting the bigger order because this is what I am actually intended for. In a bigger matrix, I don't want to write all numbers. That's why I'm doing this. Matrix with the multiple numbers without writing manually. Is that ready?
Yes.
If you can take your cursor onto this once, you see a lot of parameters you will have. Okay, you have a lot of parameters. You can also look for all the parameters. They are optional. They are not given that. So you can look for all the parameters. So it says explanation about what it is going to return. It returns a new array of given shape and type filled with ones. Okay. It's giving all the other parameters also. Yes, let's see the next one. I hope all of you are doing it. Finished? Okay. Can you try with the A range? Can you try with A range? Don't write double R, it is not arrange. I think we will get our auto suggestions. but ignore the auto solution with double R. Just look for A range. Just fix that. Easy one. Ask what is you can do this one. All right, let's take one more example on A range. How do you do that? How do you do A range? Same thing as you did here. NP dot A range. Your A range is a function available inside the numpy. You remember like this. Okay, other than remembering what to write. In numpy there is a function called A range. That's why to access that function you need to put a dot after NP. Then type A your suggestion. Suggestion will come. Then write R, you get suggestions. Like that. Okay, let's get back. Should I minimize?
No, sir, you are not seeing.
Is it? Let me check again. I'm all right. Like, use YouTube. Use YouTube. You are teaching me. Okay, so let's go with the np dot a range. Let's go np dot a range. I have the a range. I just wanted to read a brief about the a range. It says I have a stop value and also have a this is start value, this is stop value, and also have a step value for this a range. So that's why I can use any one of them. So what it does, it returns evenly spaced values within the given interval. So parameter is start, stop, and end. Any one of them we can give it. Okay, so let us write something here. So I can write 2. Okay, what should I print? Should I print ARR after this? Okay, I'll use ARR for this. 0, 1 will be the numbers, and I'm having only 2 numbers, 0 and 1. Any number of values you want, you can keep them. It's up to you. Then we have evenly, even the numbers you can specify set as index number generate number generate index on we start 0 and let us start with 10. Let us start again. Let us do that. And 10 will start again. 20 then we can give 20 minutes of content. But the start 10 will start at 10 model 11 model. Let us give 9. Then we start with it. Let us start. 9 is start with start with 9 number. Let us make 9 and end with 21. 22 it is not 16. I am generated now. I have given 21. It's not 21. We give 1 less than 20. I have given 10, 21. It is printing from 10 to 20. 21 is not taking. When I give stop value as 21, it will stop at 20. 1 number less. Try that thing. 10, 21 or whatever number you write, just write that. np dot a range. And in bracket there are some numbers. Table what happened? No, if you are looking this. Is it on? Yes, you can start it. You can comfortably move that PC and comfortably stay. Is it done? Okay. Alright. So one more number we have given, comma, 2 we can write. When you write 2, you are actually skipping 2 numbers and you are jumping to the next number. When you do that, you are actually giving the step value. Step value, the last one. Try and see what will be the output. You will have fewer numbers. I have the 6 numbers in added here. Out of 10 numbers, starting from 10 to 20, only 6 numbers I am available. When I am giving step angle as 2. Alright. So how it has jumped? Let's see. It has jumped 10, 11 it has skipped it, directly it went to 12. 13 it has skipped, 14 it has went off. Alright, that's why it is 2. If I use 3, it is going to jump 2 and third number will jump it. 10, 12, 11 and 12 skipping, 13 is jumping. From 13, 16 skipping. Alright, if all of you are trying, you can go to the next one. All of you are done? Sorting arrays. Can you sort the arrays with the okay, we also had a sorting in terms of list, right? So let us look at here also. Sorting an element in a simple way of np.sort, np.array, then you have created an array in an ARR, and if you use np.sort as a function, and if you give ARR into this one as an array, then it will sort those numbers and give it to you. And the output goes like this: 1, 2, 3, 4. If they are unsorted, like 2, 1, 5, 3, 7, 4, 6, 8, it is sorted like this and printed from 1 to 8. Alright, this also we can use it. And then, same way, since it is a numbers, it is sorted in terms of numerical value. When you have alphabetical data like banana, cherry, and apple, so it is sorted them in terms of alphabetical order, dictionary order. Okay, so that way. For example, we have taken banana, cherry, and apple. So np.sort same array that you have created just now with array. Then you can have printed apple, banana, and cherry according to that it has been there. You just write your own keywords and try to understand whether they are sorting in terms of dictionary or not. Let's look at this example. What do we need to create? We need to create an array of numbers. Then use the np.sort. Quickly do it. I'm using the previous imports. I'll not be writing the import. I will just writing np dot array. I'll be creating some elements here because I want to manually. I can also use my range, right? A range, but it will generate the sorted numbers already. Okay, I'll write the array itself. You can use array itself and manually type the numbers, unsorted numbers in the list. I have 2, 1, 5, 6, 3, 8, 7, 4. I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 numbers ready in a randomly arranged. So this I will store it in ARR. I've stored it, and here I want to sort them. NP dot. I have a function inside the NP called sort, and I want to read something about the sort function. It says I have an array, I have an axis, I have a none. I have kind of the parameters. So what it returns? It returns a sorted copy of an array. It returns a copy of the array. It doesn't affect the existing array. Just return the copy of the array, but you need to store them. Then only its existence will be preserved. Sorted state will be preserved. Okay, I will give ARR as my sorted numbers. So I want to print that thing. So that's why I'll use the sorted array equal to. I have taken a variable. I have taken my array element array identifier here, and here I'm going to print them. Yes, my numbers are getting sorted as I have unsorted numbers. Okay. Yes.
It has some installed from only base.
Yes, done. All of you. Let's go ahead with the next one. We just created array with the random numbers, and now we are able to have sorting. So you just need to remember them whenever you have the facility. I mean, whenever you need this facility, you need to remember this facility and use them. That's what the purpose of learning this thing. Let's go ahead. How about alphabet? You do alphabet and let me know if you have, if you are able to sort them. Same process. Data is changing now. Instead of 1, 2, 3, 4, we are going to write the names in the double quotes. Do that fast. Same code, no change. Elements will change. Okay, I started it. Just try all of you.
Every time I run a program, I get a easy other journal to send to
They're not doing your thing.
yeah, yes,
I'm not writing your things. All of you have done this. I think all of you understood the capabilities of numpy in terms of handling numbers and matrices as well as the stream of characters. That's perfect. Okay. So we have finished till this minute. You may be an teachment to join it, but don't miss this. All right. Thank you, all of you. We'll continue tomorrow.